Okay, here we're looking at solids of revolution, the washer method. The problem is find the volume of the region that is between the functions and is rotated about the x-axis, having the boundaries of x equal to 0 and x equal to 4. First of all, what you need to understand is what the functions are. The function for this one is, we'll call it f of x, and that's equal to 2x. The second function, which is the one on the bottom, which is below, we'll call it g of x, and this one is defined by x to the power of 3 over 2. Now, what they want us to do is to rotate the region between, and in essence they want us to rotate these two functions about the x-axis. So it's going to create a 3D image, and so first of all, since we're going to rotate this function f of x, is going to actually, it's going to look like almost like if it reflected, and it's going to be somewhere about here, okay? And the other function, g of x, is going to look somewhat like this. Okay, so those are the two functions, but see they've indicated that we want it to rotate, so it creates an image of, if we look at it, and we'll look at it here right in the between the limits. I know that they're saying that the limit is 4, so we're going to be looking from this boundary to this boundary because that's 0 and this is 4. But I'm going to show you the cross section of it. The cross section of it is going to be compared to the disk method, which it looks like a circle, okay? But more, if we only look at one function. If we look at the innermost function creates another circle as well. And so this changes the view of a disk to a washer, because the thickness of the washer would be defined by d of x. So let me just show you the shape of the washer here. And so if I concentrate on that, the washer would look like this, and the thickness of the washer is defined by d of x. Okay, now to find the area of this washer, we subtract the areas of the surface here. So kind of like what we did in compositions in geometry. We take the area of the bigger circle and subtract it from the area of the smaller circle. So we know that the area of the circle is defined by the area is equal to pi r squared. Okay, so that's the area of a circle. But we're trying to find the volume here. They're asking for the volume. So the key is to find the volume of the washer. So we're gonna actually do this. We're gonna find the area of this washer first, and then we can multiply it by d of x. Okay, and we're gonna use the integral to do that. Okay, and I'll show you what the integral does after we do that. But first of all, our job is to find the area of this, and that's going to be pi r squared of the larger circle minus pi r squared from the smaller circle, and we can factor out the pi, and that's just going to give us r squared minus r squared, and we can call it this one RL larger and this one RS smaller. But these are going to change to become functions. The larger circle is created by the function f of x. So we can write this as pi f of x, that squared minus g of x squared, okay? And that's going to give us the area of what we've shaded there. So now, the integral takes part, so we use this, and we need to multiply by dx to get the volume of this, okay? But we use the integral to take care of that. So let me show you what we're going to do here. We're going to use the integral from 0 to 4, okay? And we have the pi times the function squared minus the second function squared times dx. You got to understand that this is the actual volume of the washer. Now, what the integral's job is to bring everything else into play, like all the other washers that are going to be constructed from the other slices. If we keep on slicing this, you know, actually it's smaller than this thickness, but all of these are going to be sliced, okay? And even beyond 2, I sliced it here at 2, but what if we had beyond 2? We would have more discs. So these are the discs that come out of there, all the way up to where 4 is, okay? So this is, I'm not showing you the inside of it, I'm just saying that if we slice it, we already know what it would look like, because I showed you that washer there. So yes, all of these would be washers when we take them out of there. Okay. So now that we understand that, we continue here with this integral, and we can reduce it. And well, actually, we need to substitute in the functions, and we can reduce after that. So here we got the first function, which is 2x squared, comes from this equation that we came up with. And then we have x to the 3 over 2 squared, all multiplied to dx. We can simplify, and this is going to become 4x squared minus the 2 and the 2 cancel out, so that's just going to be x to the 3rd. And that's going to be all dx. We have a pi up here. Okay? So, now, if I continue this, let's move it over here so we can have more room. We're going to be able to take the integral of that, and the integral becomes pi with the limits from 0 to 4. We'll take the integral of 4x squared, so that's going to be x to the 3rd, and divide 4 by 3 minus x to the 4th, 1 over 4, okay? And that's our integral there. So now I have to introduce the limits. Now when I introduce the limit of 0, which is the second thing that I do, it's going to end up becoming 0, so I don't have to worry about that. So first and only I want to just introduce 4 in there. So we get 4 to the 3rds right there, and then we have 4 to the 4th right here. we get a calculator, and we find out, to make it easier for now, we had to do it without the calculator. We could, but it takes us, some times. But just to be a little bit quicker, 4 to the 3rd is 64. So we get 4 times 64 over 3 minus 4 to the 4 is going to equal to 256 over 4. Now, we can try to simplify this, and let's see, or we can have our calculator try to simplify it for us. 64 times 4 is going to be 256. 256 over 3 minus 256 over 4. We can do a quick, we can find like terms, or we can just do it quickly on the calculator. 256 over 3 minus 256 over 4, and then go to math 1, and we're going to get 64 over 3 pi. That's our answer. So the volume of this, again, is going to become 64 over 3 pi. Just in case if you don't see it down here. 64 pi over 3. And actually it's units, cubic units, because it's volume. Okay. Now let's write a general formula for the washer method if we have two functions that we want to look at like this in this scenario. So volume is going to be equal to pi, the limits of A to B, which is lower to larger limits, boundaries, and then f of x squared minus parentheses g of x squared, the integral of all that. That is our general information there. This is when you have two functions that create a region between them, and then you want to rotate them and create a solid, okay, which is called solids of revolution, the washer method.